I'm doing reference angles in degrees. All right, so in the previous video, we talked about what a reference angle is, and we said that it is the acute angle that is made with the terminal side of an angle and the x-axis. So terminal side of an angle, this is the x-axis, the acute angle is going to be this guy right here. This is the x-axis, the terminal side is here in quadrant 3, boom, there's the acute angle that you can make. So I have it drawn out here for all 4 of the quadrants, what a reference angle would look like depending on where your terminal side is. Now, notice that with this one, I have it, all of these angles are just like in their first rotation, but it doesn't matter how you get to the terminal side. I could have come to the terminal side this way by going like negative more than 360 degrees, right? I could have got there this way, and my reference angle would be the same, because the reference angle doesn't care how you got to the terminal side. It just cares about what the terminal side is and where the x-axis is, and that it becomes your reference angle. So I'm going to give you formulas for each of these quadrants here, and that's my son. I'm going to give you formulas for how to find the reference angle in each of these quadrants here. However, honestly, I don't think of these as formulas at all. I just kind of derive it each time, and I think it's a little bit better for your brain when you do it that way, when you just kind of think it through and come up with the formula on your own. But let's do the formulas anyway, for fun. Right? So in quadrant 1, here's the nice thing. As long as your original angle, so I need to make this note here, as long as theta is between 0 and 360 degrees, these formulas will work. So while it doesn't matter how you get here, the reference angle will be the same regardless of how you got there. The formulas I'm about to write down right now are assuming that we're talking about the angle that is between 0 and 360. And you can always find a coterminal angle. We'll talk about that in a moment. But assuming that theta is between 0 and 360, like this picture here, theta in the first quadrant, the reference angle is just theta. It's the same. The reference angle is the angle. Boom. Wham, bam, thank you, ma'am. All right. In quadrant 2, this entire distance would be 180. Maybe I should use smaller pen there. This would be 180 degrees, right? Sorry if that made a lot of noise. I moved my webcam down so that the microphone was closer. That's 180. Right here, this guy we know is theta. So as I had mentioned before, this reference angle is 180 minus theta. 180 degrees minus theta. For quadrant 3, I'm still going to think about this 180 degree mark here. But this time, theta is a bigger angle. So I want to find this little piece right here that's missing. Right? This is 180 degrees. This is 180 degrees. Theta is a little bit more than that. I want to know how much that little bit more is. So I'm going to take theta and I will subtract the 180. So I'll take this whole thing and then I'll just subtract out this part and I'm left with the leftovers. So our reference angle is our theta value minus 180 degrees. For quadrant 4, I use a little bit different reasoning here. I know that the whole way around the circle is 360 degrees, right? If I do the whole darn thing, that is 360 degrees. In quadrant 4, right, this theta angle takes up all of that, and there's a little bit left here. So it's the whole circle minus this part of which is theta. So 360 minus theta will give us our reference angle. Right? So those are the formulas for finding reference angles as long as your theta is between 0 and 360. So here's the deal. If your angle is not between 0 and 360, let's say it's more than 360 or it's less than 0, you need to start by finding a coterminal angle that is between 0 and 360. You need the angle you're working with to be one that is between 0 and 360 to make the math nice. There's ways of doing it without finding the coterminal angle, but you're making life harder for yourself. And if you want to do that, that's fine. But I'm not doing that in my video. So this is just a review of finding coterminal angles. If you're more than 360, you can just keep on subtracting 360 until your angle is between 0 and 360. And if you're less than 0, so if you're negative, you just add 360 until it's between 0 and 360. Like I said, I don't memorize formulas. I just make a sketch each time, and I use that to figure out where my reference angle is. All right. So for this first one here, this 252 degree, where we're trying to find the reference angle, this is already between 0 and 360, so we don't need to find a coterminal angle. And then I draw out this little picture. And honestly, I don't think you can draw this enough. I think you can't write down 0, 90 degrees, 180 degrees, 270 degrees. You can't draw this enough. All right, so 252, we know, is going to be here in quadrant 3. So this is 252 degrees. The reference angle is going to be right here. So that one is going to be 252 minus 180 for the reference angle. (252 degrees minus 180 degrees. And that gives us a reference angle of 72 degrees. Not so bad. Let's go ahead and do negative 405 degrees as well. So this guy's negative. That means we need to find a coterminal angle that is between 0 and 360. So I start by adding 360. When I do that, I get negative 45 degrees. So I need to add 360 again. And this next angle will be 315 degrees. When you start with a negative angle and you're adding 360 to get something coterminal and you want it to be between 0 and 360, with the negative angles, if that's where you're starting, you just add until it becomes positive. The first time the number becomes positive, that's where you stop. All right, so we're looking at 315 degrees as the coterminal angle here. So essentially what happens is, so 315, well, let me draw a picture down here. I'm going to draw it anyway, might as well draw it down here. 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. 315 is here in quadrant 4. Right. And you would get to it like this. That would be 315. I just want to mention that negative 405 degrees would still have the same terminal side here. It's just it would have been reached a different way, right? It would have done, this would be negative 360, and then let's see, negative 360, and then a little bit further would be that 350 would be this terminal side here, negative 405. So they have the same terminal side, which is why it doesn't matter how we got there. It didn't ask me to draw it in standard position. It just asked me to find the reference angle. So this picture is not showing negative 405. That picture shows negative 405 degrees in standard position. This one shows the coterminal 315 with its terminal side. All right. Our reference angle is right here. for that one, we're taking the whole circle, so 360 degrees, and we're subtracting out our theta, which is 315. So 360 degrees minus 315. And that gives us a reference angle of 45 degrees. Boom. I want to emphasize one more time that the reason I'm finding these coterminal angles and able to draw negative 405 like this instead of like this is because I was not asked to put something in standard position. I was not asked to draw something in standard position. If I were asked to draw something in standard position, it would have looked like this instead. But if I'm just finding the reference angle, this picture is just for my own good, and it doesn't matter. All right, well, that is it for this section. So that's finding reference angles in degrees. We're going to go over a little bit of radian mental math in the next video, and then the following video we'll be doing the same thing, but with radian measurements instead. I'll see you in that video. Bye.